All right, so the first thing I want to do today is we're going to spend just one more day doing rotating coordinate systems, and then we'll keep revisiting that because it's complicated, hard to wrap your head around. But the first thing I want to do is give you a problem. I want you to work on it in groups. Get together with the people next to you, and then. Do we have? Oh, yeah, we do have a lot of markers. So I want you to come up, once you come up with an answer for this, and write it up on the board. You can do it anonymously, but people might see you doing it, so then. Okay, so that would be the polite thing to do. But since your eyes will be closed, you'll just have to assume they got it wrong. Ooh, I got sloppy at the end there. Okay, so what we have is a disk rotating horizontally this one has, so we'll call this one body 1, and it has a radius of 0.5 meters. And then we'll call this one body 2, and it has a radius of 0.2 meters. And then on disk 2, there's a point P. There's a particle at that location, and the mass of that particle is 0.05 kilograms. Okay, so body 1 is rotating with a constant angular velocity of 10 radians per second. And body 2 is rotating with an angular velocity of 50 radians per second that way, and right. And the angular acceleration is positive 100. Negative, you know what I mean. Maybe you don't know what I mean. And the question is, okay, so can you follow what's going on here? This one's spinning this way with a constant angular velocity. This one's spinning this way, and actually, I just drew that wrong. I meant it to go the other way. So it's speeding up, which means it has to be like this. So it's spinning like this, speeding up. And you need to calculate the net force on that particle P. Okay? Planning to go through this, but it seems like everybody's doing it. Let me go through it the hard way, I guess. Okay? Okay, so the easier way is to put your origin rotating with body 1 at A, so your origin at A, and your axes rotating with body 1. I'll do it with your origin at B rotating with body 1. Okay, so if the coordinate system, if the origin is at B and it's following body 1 around, is the origin accelerating? Yes. So we need to use relative motion. The second question is, are the axes rotating? Well, as long as we're in this section, that question always has the same answer. But later on, when you have to recognize these kind of problems, differentiate them from other kind of problems, this way of thinking about it is a good way. So are the axes, whoops, I meant to say rotating? Yes. Okay, so the acceleration of P relative to the ground is equal to the acceleration of P relative to the origin plus the acceleration of the origin relative to the ground. The acceleration of the origin relative to the ground is a circular motion, and so we have to use the watermelon equation for that. Okay, so what are lowercase alpha and lowercase omega for the circular motion of that point B? So that point B is spinning around with body 1. So its angular velocity and angular acceleration are the ones for body 1. So we're just going to have an omega of 10 in the y direction and nothing for alpha. So alpha is 0. Omega is 0, positive 10, 0. And then we need an r vector. What's the r vector for the circular motion of that point B? In what direction? Yep. In the positive x. So 0.5, 0, 0. And so the acceleration of the origin relative to the ground is equal to alpha cross r, that goes away, plus 0, 10, 0, crossed with the quantity 0, 10, 0, cross 0.5, 0. Bless you. Excuse me. That was weird. That was an out-of-body experience. 0, 10, 0. And this one is 0, negative 5. And so you get an acceleration of, that's not right. What did I do? 0, 0, negative 5. And so you get negative 50, 0, 0. Does it make sense? Okay, so Is there any sanity checking you can do on that to make sure that that direction makes sense? What do you know about the motion of the origin? It should only be centripetal acceleration because there's no angular acceleration, so it should be pointing from B towards A in the negative x direction, so that makes sense. And now we have to go to the acceleration of P relative to the origin. For this one, we're going to use the rotating coordinate system equations. So we have the observed acceleration plus capital omega cross the position vector plus 2 times capital omega crossed with the observed velocity plus capital omega cross quantity capital omega cross P capital omega is equal to 0, positive 10, 0. Capital omega dot is 0 because body 1 has no angular acceleration. What's the position vector in this coordinate system? The position vector of P. Just, yeah, 0.2 in the positive y direction. And now we have to come up with the observed velocity and observed acceleration. The observed velocity is equal to omega cross r. What's the lowercase omega for if we're watching the motion of this point P in a coordinate system rotating with body 1? What's omega? 0, 0, 50. And what's the r vector? 0.20. And so you get an observed velocity of negative 10, 0, 0. The observed acceleration is from the watermelon equation. What's alpha? 0, 0, 100. R is 0.20. Omega is 0, 0, 50. So cross with the quantity 0, 0, 50 cross 0.20. And you get negative 20, 0, 0 plus 0, 0, 50 crossed with negative 10, 0, 0. So that's negative 20, 0, 0 plus negative 500 y, 0x, 0z. So negative 20, negative 500, 0. And now we have everything we need to plug into the rotating coordinate system equation. So the acceleration of P relative to the origin is equal to the observed acceleration plus the angular acceleration of the coordinate system cross P. This capital Omega dot goes away because the coordinate system's rotating with something with a constant angular velocity. Then we have 2 times omega, capital Omega, which is 0, 10, 0, crossed with the observed velocity vector, which is negative 10, 0, 0. Plus capital Omega. Is that what it was? Zero, 10, 0. Crossed with the quantity 0, 10, 0. Crossed with the position vector. Bless you. Excuse me. Negative 20, negative 500, 0, plus 0, 0, 200, plus 0, 10, 0, crossed with, did I do that wrong again? No, that's right in this case, right? Those are in the right spots. And so you end up with negative 20, negative 500, 200. So the total acceleration of P is equal to negative 20, negative 500, positive 200, plus the acceleration of the origin relative to the ground, which was negative 50, 0, 0. And you get negative 70, negative 500, 200. So F net is equal to 0.05 times AP, and you get negative 3.5, negative 25, positive 10. And I have to admit, I still think it's cool how that works out, you know. You have all these, like, I'm still always, like, slightly surprised when it works out. You have all these terms in there that, like, totally different. They don't look anything like it, and then you add everything up at the end, and it comes out the same. It's awesome. All right. Any questions about that? This is the end of what I'm saying in class about rotating coordinate systems. Okay.